Hey guys, this is Mark. In this video, I'll be talking about numeric data types supported by the BackEndless database. There are 3 different data types supported, and there is one shortcut, and we will be reviewing them all. Things could get rather complex with subtle differences between some of the types, but nevertheless, let's take a look at what's supported. There is a slide here that I'd like to show you. As you can see, these are the core numeric data types: int, double, and decimal. Int is rather easy to understand. Whole numbers, there are no fractions. So anything that is data that doesn't have fractions, and we talked about age, there may be anything else that represents a whole count integer will work, and int supports a rather large range of data. Double is a floating point with double precision. That means that it's a very, very large range of data, and for some of the scientific data, it is not recommended because of the precision does not give you the actual super precision. So there may be some variations when it comes to the calculation, and it could get very scientific. For the majority of applications, it doesn't really apply. Decimal has a fixed precision and scale, and what it means is that you designate how many numbers are going to be appearing after the decimal point. And the differences between decimal and double is that there is a fixed point versus a floating point. Let's take a look at the ranges. So int, these are the ranges supported by the BackEndless database. As you can see, these are huge astronomical numbers supported by int. And with double, it gets even larger. So these numbers are actually humongous. And then double, unlike int, supports a floating point. So for instance, if you need to store data that represents currencies, and your currencies may go from very small to very large, then double would work for you for that case. Decimal is a fixed point, and when you define a decimal data type, and we'll take a look at how it is done in console, there are 2 values that you need to provide. One is the precision, which indicates how many digits are going to be total in your numbers, and that includes digits after the decimal point. And scale is the number of digits that actually come after the decimal point. So that's decimal. There is going to be another type that is called money. And money is the shortcut for decimal, where the precision is 10, so it supports 10 digits entirely, and scale is going to be 2, which is convenient to represent fraction of currency. So those are 3 data types, and let's go back into BackEndless console to actually see how you would go about defining and configuring these data types. In BackEndless console, we already worked with int when we were defining schema for the person table. The age column had the type of int, and that is a whole number, which is very appropriate to express age. Let's say we want to define another type, and let's say we will be using double to represent person's worth, financially speaking. So here we will say that the column name is worth, and if we select double, again, this is very similar as we had with string. You cannot specify default value, constraints, which are the same as with string, and a validator. The validator has to be a numeric validator. If you were to define the column as double and select the validator as, let's say, IP address or HTML tag, then it will let you save it, but you will not be able to store any data because it will be validating against a validator that is, let's say, HTML tag, but the numbers will have to be numeric, and it will always be an error. So if you are defining a validator for double, make sure that you pick a numeric validator, or if you use the custom one, it has to validate against numbers. So here, if it is double, click create, and now going back to data browser, here you can start entering some very large values. Okay, so those are going to be stored as double. Whenever you run an API to get that value back, you'll get exactly what is entered here or whatever you're saving with the API. So that's very straightforward. Let's take a look at the data type that is decimal. So here is decimal. And as you can see, there are these two parameters: precision, which is the total number of digits in the entire number, and scale, and that's how many numbers are going to be after the decimal point. 10 and 2 are going to be exactly the same configuration parameters, where if you select money, here's the data type money. In this case, you don't set precision, you don't set scale, and those are going to be assumed by the system because internally it will use decimal with 10 and 2 for the configuration. So whether you go with money or if you go with decimal, the default setup, it's going to be identical. Okay, so for instance, if there is a column called hourly rate, which is probably not very appropriate for person because some people will have an hourly rate, let's say where they are employed, and some people may have a salary. So, but this is just for the demo purposes. So if we have, let's say, this hourly rate, create, and going to the data browser, here's hourly rate, and we can say, let's say 25.50. Okay, so and that becomes that decimal. If I were to enter something that is, let's say 20, and I start entering these numbers, okay, it will truncate it to the 2 digits after the decimal point. It will actually do the rounding as well. So for instance, if I say 35.256, okay, since 6 is greater than 4, it will round up to 35.26. Let's take a look, and as you can see, it is 35.26. So that rounding up or down based on the mathematical rules will apply whenever data is stored for the decimal and actually for the double as well. So that's all we have. Fairly straightforward, although once you start getting into the ranges it could get complex. Fortunately, not a lot of applications deal with these humongous ranges, and for the majority of them, having decimal and integer would be sufficient. Speaking of decimal versus double, something to keep in mind. Double, while it is floating point, and there are some inaccuracies that may come into the calculations, especially when you have a lot of digits after the decimal point, and those are the scientific calculations. Double yields better performance. So if you use double and you have a lot of data in there, then double will work faster than decimal. It's just something that comes directly from the database. Other than that, pick the one that works the best for your application. Thank you for watching this video. I hope you found this useful. And as always, happy coding.